Okay. I hope I'm not echoing on you guys.
It is, but that's fine.
I'm just dual. Like trying to figure out how to make it stop. Okay, so lesson 5, part 2, number 6. Are you guys all there?
Yes.
There's like some weird echo. You guys hear it?
Yeah,
Yeah, it's echoing.
Mine's not.
Okay.
That fix it? No.
I don't know.
I'm trying to figure out where my.
It's probably a setting.
Not planning on speaking either feed. Okay, so number 6. I apologize for echo, guys. I don't know what. I'm going to turn my thing down a little more and see if it'll. Nope. Oh well. Okay, so for number 6, for the U.
mean, I got 150.8.
Yeah. And then 8.8% standard deviation.
Yes.
That's what they just said.
And then part B, what proportion of people who take the quantitative portion of the GRE will score above 165? So I did this finding with the Z formula and got 0.0533.
Mm-hmm.
Me too.
Yes, ma'am.
Okay.
Okay. Jason, do you want to do C?
Yeah. It says if a student scores in the 10th percentile, what would their corresponding Z score be? I got negative 1.28.
I'm having a hard time hearing you, Jason.
Yeah, I can't hear Jason.
Oh, okay. Can you hear me now?
Kind of.
Can you hear me better?
It's really faint.
I don't know. Here, let me switch over to her. I'll join back in the call just a second.
Okay, let's see if him coming back to them.
Yeah, we'll make it. Well, stop. Does it stop my echo now? Can you still hear me?
Yeah, we can hear you, and I don't hear an echo anymore. So.
Oh, good. It's really annoying me to hear it over and over. Let's wait on him for a second. Is he able to get back in, or do I have to invite him back in?
I think he might be able to, but I might want to invite him just in case.
Where's his email address? Okay, I sent him the invite, so hopefully he can get in that way. I feel bad for you guys. This had to be one of the most boring videos you ever watch.
Don't worry about it. It's not about the entertainment of it all.
That's it. Oh, he's coming.
So, what lesson were you planning on doing today?
We were going to see how far we could get through 7.
Can you hear me now?
There you are. Can you guys hear him?
Yeah, I think. Say something again.
Can you hear me? Hello?
Yeah. Oh, there we go.
That was weird. Some with my iPad.
Nice. All right, you are on 6C.
6C. Oh, okay. If a student scores in the 10th percentile, what would their corresponding Z score be? Negative 1.28.
What I got?
Yeah. What quantitative GRE score for a student who scores at the 10th percentile? So this one asks to round it, but I got 140. It was 139.5, but you rounded it up to 140.
That's what I got. All right, 7. The mean speed of hydrogen at room temperature is 1,800 miles per second with a standard deviation of 600 miles per second. I assume that's what that means, MS.
Yeah.
At room temperature, the mean speed of hydrogen, H2 particles, is approximately normal with a population mean of, and so then the U is going to be 1,800 miles per second, or meters, that's what it is, meters per second, and a standard deviation of 600 meters per second.
Yes. Okay. And what is the probability that a randomly selected particle has a speed over 2,500 meters per second? 0.1216.
That's what I got.
Okay, what is the probability that a randomly selected particle has a speed that is less than 2,500 meters per second? I got 0.8783.
That's what I got. I got 0.8784, so close enough.
Okay.
Yeah.
Okay, so let's see here. D. What is the probability that a randomly selected particle has a speed that is less than 1,500 meters per second? And I got 0.3085.
Yeah.
Okay, E. What is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? I got 0.5698.
That's what
Yep.
I got.
And then F, what is the third quartile of the speeds of hydrogen at room temperature? And I said it's 2,204.4, 2204.4.
Do either of you know how that was calculated?
I
I'd like
They-
added the
you ha-
standard deviation.
So you had to change the applet area to the 0.75. And that gave you your z-score, which was 0.6745. So then you just made that into the z-score formula. So it was 0.6745 equals x minus 1,800 divided by 600.
Yeah, for these ones, did you guys use applet?
Yeah.
Okay, yeah.
Okay. Because I was
Does
thinking.
that make sense, Jason?
Yeah, that makes sense. Because I was thinking just the third quartile would you just add the standard deviation to the mean, and which was 2,200. But that makes more sense. Because I was close, but I couldn't figure out
Yeah,
how.
so it's crazy that it was pretty darn close there.
Yeah.
Okay, so 8 says determine whether the data represented in these QQ plots are normally distributed or not. Record your answer for each graph and justify your answer. And so for plot A, I got not normal because it's not a straight line. It's all over the place.
Yes.
I got the same for plot B as well.
C, I put yes. It is straight right on the line.
Yeah.
And then D would be normal because it's even straighter.
Yep. E is not normal, just because it's close to normal, but
I got normal just because it is still a straight line and the plots that are off are kind of the same and stuff. So I think it's normal.
let me check in the answers really quick. It's saying it's not normal.
Not normal for E?
Yeah.
It looks like it could go either way, really.
Yeah, I think that the little plots that are kind of off of the line are
What's throwing it off there?
Yeah, because there's some on the very bottom left and one in the middle there.
Yeah.
So then F, I got normal.
Yes.
Yeah, me too.
All right, so should we do the quiz for lesson 5?
Yeah.
Let's see.
All right. Do you guys have Applet pulled up?
No, that's what I was going for.
Oh yeah, that's a good idea.
Oh, it has a link in the quiz too.
Oh, in the quiz for it?
Yeah.
Make it easier to find.
You guys are going to use the probability applet a lot, so I would create a bookmark for it.
Oh, that's a good idea.
Ah, perfect.
There it is. Okay, so question 3. The total area under a normal distribution curve must be equal to what?
1, right?
I believe so, because it, where's our thing?
Oh yeah, must equal 1.
Yeah, you guys have, is it positive 1 or is it negative 1?
Positive 1.
Yeah. If you highlight everything, it's always 1.
You can have a negative. I don't think you can have the, well.
Oh, should it be 0? Because wouldn't they, if it's the total area, you're going positive and negative, wouldn't they counter?
No, not in this case. This is just calculating your probability.
So it was 1, right?
Yeah,
Yes.
so the probability is 1
1.
or like 100 or whatever.
It would just be 1, yeah.
Yeah.
All right.
Okay. Number 4. Under certain circumstances, a normal distribution curve can drop below the x-axis. I believe that's false.
False, yeah.
I think so too.
I think you said it has to be on or above.
Yeah. That's what the rules said.
Yeah. Okay.
Number 5, a normal distribution curve is symmetric. That's true.
Okay, use the following image to answer the next 2 questions. Question 6, which of the following elements of the figure represents the z-score? And that would be C.
Yeah.
Okay, 7. Which of the following elements in the figure represents the probability that the z-score will be greater than 1? Which would be B.
Yeah. Question 8. According to the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? Write your answer as a percentage such as 42 rather than the proportion. So for this one, we're just looking at the chart still, right?
Yeah.
Sorry, just a second. I'm going to have to scroll up and down. What percent of the data of the bell-shaped distribution is within 1 standard deviation of the mean? Would it be the 84% because it's, oh, no.
Wouldn't it be the 68?
68 point, yeah.
Yeah,
Oh,
0.68.
that's what it's asking. Okay.
I was looking for a different answer too. And then I was like, oh wait, it's after the rule.
Yeah, it took me a second too.
Man, I feel like these questions sometimes are so simple that it's like, I just look right
So
over
simple, they're hard.
Then you get a zinger and you're like, wait, what?
It's actually a lot easier than I'm making it.
Uh-huh.
Okay, I think it's Callie's turn.
Yes, 9. Yeah, all this going back and forth. I'm like, okay. Suppose that z-scores come from a standard normal distribution. Use the normal probability app to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places.
Isn't that the same?
That's what I was just thinking, is if it's between -1 and 1, that's still the first standard deviation.
But if you plug
So
it in,
my guess is it would be 0.68.
Yeah, it's 0.6. Because Even if you do the shaded. Even if you do
Yeah.
the shaded, or yeah, if you just click the shaded area in between -1 and 1. Yeah.
I don't know what
So
yeah,
that
it should be.
0.683 then. Because
Oh,
if you put it in there, it gives you 0.6827, so you have to do it to 3.
that's right. Yeah, because it says 3 decimals.
Yeah.
Good catch.
There you go. Okay, number 10. Suppose that z-scores come from a standard normal distribution. Use the normal probability output to answer this question. What's the portion of the z-scores will be between -2 and 2? Well, that's the other one. That's the 95, right?
Yeah.
Yes.
955.
95.5 or 0.955.
0.5, yeah. All right. Suppose that z-scores come from a standard deviation or from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of z-scores will be between -3 and 3? So that would be the 99.7, wouldn't it?
Yeah, so 0.997.
Yeah.
Okay, look carefully at your answers to the last 3 questions. What do you observe? The values match the 68, 95, 99, 7 rule, which is what it should be. As the z-score increases, the area between the negative z and z decreases, or the probabilities double as you move from 1 to 2. And I would think it's the values match the rule.
Yeah, I agree.
Okay. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body weight. Body weight. Formula. The population mean protein requirement for adults is 0.65 grams. And the population standard deviation is 0.07 grams. Okay, what portion of the population will have a protein requirement that is less than 0.60 grams?
Okay, so
You
we want to ignore all that craziness because it's just there to trick us.
Yeah, that'd be annoying.
Stuff. So we need to figure out proportion of the population with the protein requirement.
0.65.
Okay, so are we going to use the Z formula for this one?
Yeah, I think so. Find the z-score and then just plug it into the applet deal.
Z equals
Where's the formula again?
It's Z equals you don't want the actual formula, not the numbers. It is Z equals X minus U divided by the standard deviation, the O thing, the line. So it should be 0.60 minus 0.65
divided by
0.07.
You divide the 6.65 and 0.07 first, though, right?
I don't. I usually do the subtraction on top first.
Oh, you do?
Mm-hmm.
Yeah. Okay, so then it's asking.
So that's -0.714.
Yeah.
Okay.
Yes. So the answer I got 0.238.
When you plugged it into the thing?
Yeah.
Okay.
All right.
Wait, sorry, you got 0.238?
Yes.
I'm seeing 0.5248.
Let me see.
Let's see. So in the z-score area, you put 0.714, right?
Yes.
And then did you shade just the center?
No, I shaded just the left part because it wants to know who's less than who would have less. Wait. Let me
Oh,
see.
sorry. You're right. Okay, yeah, so 0.234. Yes.
Yeah.
Got it.
0.23. I got 0.2376.
Yeah.
Oh, yeah,
Yeah.
so
Then I rounded that to 238.
Oh,
okay,
okay.
so 0.238.
Oh, right. Okay. Sorry. I heard 0.234.
So did I. I wrote the wrong thing too. I think I said
Oh.
4, so I'm sorry.
Sorry, I might have. Sorry.
All right. What proportion of the population have a protein requirement that is more than 0.60? So let me pull that up. I got 0.237, 0.238.
Yeah,
That's the same.
answer.
Yeah,
That's easy. Nice of
that
me.
makes sense because it's symmetrical. So
Makes sense.
Okay, so what proportion of the population have a protein requirement that is less than 0.70? So we've got to change our Z.
I got negative 8.585.
I got the same
I
one.
got 0.278.
So what question are you guys on right now?
We're on
15.
15, yeah.
Okay.
Okay, so when I did the Z-score, I got the same
Yeah,
0.714. Did you guys get that?
Yes.
Just a sec.
Note whether your z-score was positive or negative for both like sets of the equations when we were dealing with these details with like the mean protein requirement 0.65 and all that.
Okay.
I'll help you determine your answer whether it's correct or not on the applet.
So it would be just 0.38 again, right?
The point for the area, let's see. See, I still got the 0.238.
Yeah, 0.23. That's what I meant.
And if it's it's less than. Sorry, I'm on the positive still. Yeah, so still 0.238.
Yeah.
Okay, yeah.
Okay. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7 grams. Hint, remember that to find the area between two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability of randomly select observation that will lie between two values. Okay, so.
Oh, okay.
So, but for us, our areas were the same. So wouldn't it be 0?
Yeah. Well, it's kind of a confusing question.
Yeah, that just seems weird though.
Because you subtract one from the others, you get 0. So.
Yeah, it just seems weird that like the answer is 0.
Yeah, that
Yeah,
doesn't
I
seem.
don't know how it would be 0.
See, it makes me worry that we've missed something somewhere.
Okay, so I want you to go ahead and calculate the z-score for both 0.6 and 0.7 and see what you get.
We got the same number.
You get the same number? Okay.
Uh-huh.
So what you're going
One
to
positive, one negative.
enter one of those values into your z-score and just shade the middle.
Okay, it's 0.5248.
Yeah, because it looks like here in between the two values, so what you're going to do is above the 0.60, and below the 0.70, which you should be getting for the 0.6, the z-score should be negative because you do the 0.6 minus the 0.65.
Yeah, that's what I have a negative z-score.
There you go.
Oh, sorry, guys. Hang on real fast.
And then the 0.7 should give you the same number but the positive value.
Okay.
Oh, okay. I get you. So
Hello?
then
Mm-hmm.
so then the answer would be 0.525.
Okay, so you're saying we should take the area from the left or sorry, I missed what that part was.
Okay, so the way that it's going to end up working is since both values that we're calculating the z-score for
Uh-huh.
are equidistant from the mean, they're going to be the same z-score, only one will be negative and one will be positive. You see where I'm going with that?
Yeah, so I see so that one's negative, one's positive. So that the mean sorry. So for 16 then is it the area answer then, the 0.5248?
That's exactly what it is. Because the
Oh.
area is calculating your probability.
Got it. That makes sense.
That one's tricky.
Yeah, it's kind of tricky, but then once you get it, it's like, oh, it's easy.
Mm-hmm. Yeah, that's going to be the easier way to do it. I remember learning like this way to do it, and I got so confused. And then when someone told me that if it's basically the same z-score, only one's positive and one's negative, you could just shade the middle. And I was like,
Oh, okay.
Makes way more sense.
yep. Because I mean, when you're looking for something like underneath, you shade to the left of that z-score. If you're looking for more, you shade to the right of that z-score. So it would make sense that if the values of the z-scores are the same except for the positive negative difference, you shade the middle because you're looking for the in-between.
Perfect.
So 16 is 0.525.
Yes, because 3 decimals.
Yeah.
Yeah.
Hello?
Hello.
Hello? All right, my kids just started school today. I keep getting this call saying it's from the school, and then they keep not talking. So I'm like, I hope my kids are alive. Hopefully they're just doing random like tech or messages out, making sure phones work.
Yeah, and hopefully if your kids weren't okay, they would actually talk to you.
Yeah, that's right. Yeah, it's like communicate if there's a problem. Okay, 17. Find the 35th percentile for the protein requirement for adults. Round your answer to 3 decimal places. So I assume we're still going off the same information and we're just changing our z-score.
Yeah.
Yeah.
Is that what you guys are seeing? Yeah.
Oh, okay. So what? This one is you have to put in the 0.35 into the top into the area, and then the left number is your z-score, and you kind of like reverse to the.
What you're looking for.
Yeah. So you have the equation, and you put the z-score in, and then you just leave x for the number. You leave x for x, and then you just solve for x.
Okay, so you put in your area of the 0.3.
Yeah. So that though, you should always like keep just the left shaded.
Just the left shaded?
Yeah, because that's gonna cause you to like, because if you like, for example, if you have like both the left and the right shaded, and it should just go back to just the left, but it can cause a bit of a difference because like if you just shade the middle and put in 0.35, it causes something different, and you don't want that.
When you shade it to the left, it
You just shade to the left.
the area.
And you guys for the z-score got negative 0.385.
Yes.
Yeah.
Yeah, and then you just solve for it.
Okay, I got 0.67695.
I got 62305.
Yeah, I'll check my math again.
Let me just check my math real fast.
I'm trying to find, okay. Yeah, I think I did that wrong.
What did you get, Kate?
I got like I got 0 point, hold on. I just did the equation wrong. I just plugged in the numbers wrong.
Oh, okay.
No,
Let me
I
check.
agree with you. Jason, you got 64811.
Just a second, I'm doing it again.
Okay.
I got 623. I didn't put the negative 0.38 the first time.
Perfect. That's
Oh,
what I've
did you
got.
do the
62.
positive one?
So to start out with the equation, you guys had negative 0.269 equals x minus 0.65 over 0.7, right? Or,
It was negative 0.02695.
Whoa, where are you getting 0.2695?
Or sorry, no, that's my answer. Sorry. No, for the problem, yeah, I got what you were saying.
wait, your answer is negative 0.2695?
No, that shouldn't.
No.
Yeah, that's
No, my answer is 0.6230.
Okay.
Now I've confused myself. Let me double check my math.
I got the same thing.
One of
You
you.
got that too? Okay.
Yeah, 0.623.
Perfect. Yeah, I got that twice. So.
Okay, I got it.
Got it? Okay, find the 80th percentile for the protein requirement for adults and round your decimal point. So same thing, only 80th.
So did you guys get a z-score of negative, oh wait. Negative 0.842.
42, that's what I got. Is that what you got, Jason?
Yes.
Perfect.
Which value are you using?
For the area, we put in 0.80,
Okay.
and then our z-score came out to be negative 0.842.
Okay, what are you basing that off of?
The normal probability applet.
Okay, so you want to go to the one where the blue stops. Go to the z-score where the blue stops.
Okay, so it's positive 0.842.
Yeah,
Okay.
which makes sense, right? Because it's
Right.
happened.
Yeah,
Like if it were 0.50, you would see that it would go to like directly in between, like in half. You'd have a z-score 0. Do you see that? Like if you were to do that.
The standard deviation is 0.07, right?
Yes, the bottom number.
Yeah.
Yeah. So I got 0.70894.
Yep, same.
So since we're rounding to 3, it'd be 709.
Yep.
yes.
Right. Is that all of them?
I can submit it.
Okay.
Okay, question 14 and 15 are wrong.
14 and 15?
Yes.
Okay.
The answer, okay, so we put 2.238 for both of those, and the answer is 0.762 for both of those.
0.762?
Yeah.
So somewhere our math was wrong. Do you want to open it back up, Kate, and I'll give you the
Yeah.
rundown? That's 3.6.
Okay. Thank you.
All right, so 3 would be 1, right?
Sorry. Yeah, let me pull that up real fast. Okay, so yeah, number 1, 2. Yeah, 3 was 1, 4 was false,
Okay.
5 is true.
Yep.
6 is C.
Yeah, 7.
7 B. 8 0.68. 9 was, oh sorry, go ahead.
I think it's 68 because it's asking about our answer as a percentage.
Which one?
For number 8,
Number 8, we put 0.68.
I put 68 on that one, and I got it right because it asks right
Oh,
as a percentage.
you're right. Good. Good thing you caught that, or else I would have gotten that one wrong.
Wait, which question?
Number 8 was supposed to be a percentage, not the decimal.
68, not 0.68.
Oh, okay.
So
Yeah,
number 9, I got 0.683.
Okay.
10 was 0.955.
Wait, what was your answer to 9 one more time?
9, 0.683.
Okay. For some reason, I thought I heard 4 decimals, and I was like, wait, hold the phone.
Oh,
Okay, keep going.
10, 0.955. 11 is 0.997.
Okay.
12 was the values match 68.95.
Yeah.
13, 0.238.
Okay.
And 14, you said is 0.762.
Yeah.
I figured out what we did wrong on that one too.
Was it that we didn't put the negative number in?
No, all it is just we did we put 0.238 or whatever we had is what's less than 60%, and the 0.762 is everything that's more. So we just did the wrong.
Oh, we just did the wrong end.
Wrong shading.
Yeah, we just shaded wrong.
Yeah, that'll get you every time.
Darn shading.
Yeah.
Okay, so then,
16.
and so were they both 0.762 or was there a negative number?
No, they're both 0.762.
Right.
Yeah, there should never be a negative number whenever you're talking about like proportion of a population.
Oh, I guess that's true. You can't have negative people.
Yeah, no.
16 was 0.525.
Okay.
17 was 0.623.
Okay.
18 was 0.709.
All right. Let's submit the.
Do you want to let me submit first so that way if it's wrong, you didn't lose both your submissions?
Yeah, good idea.
Okay, that was right.
Okay.
Yeah, got them all.
All right. Do you guys want to keep going? It's 10 o'clock, so I don't know what your schedules are like.
I'm fine with today or tomorrow or whatever.
I'm fine with going. I can't meet tomorrow at 9 is the only problem.
Okay. Then I'll stop this one and we'll start for number 6. I'll pull that one up.
Okay.
Sounds